Hello, guys. Hope you're all doing well. We're going to do a little crash course here on volcanoes and plate tectonics, and you might find this shocking. I hope everybody's seated for this bit of information. But where volcanoes show up is definitely related to plate tectonics, and we're going to explore how that all works here in this short video. So, for starters, there are a few things that I hope by the end of the week that you'll be able to understand. I hope that you can describe the three conditions under which magma can form. And 2, explain what volcanism is. And 3, identify 3 tectonic settings where volcanoes form. And 4, describe how magma can form plutons. You know, my dog right now has to go pee. So I'm going to go let him pee. Okay, we're back. He has successfully peed. All right, so anyway, for starters, I just hope you guys are all doing well, that you're happy and healthy and safe. We're all doing okay here. My dog has a urinary tract infection, so that means we're taking him outside to pee constantly, it seems like. But thankfully, we're home and can handle that. Hope that's right now that's the biggest complaint we have, which is good news. I know there are many with more significant complaints. If you guys have any questions or concerns, and this doesn't have to be strictly about Earth and space. If you've got something that's school related or something I just need to know, please reach out. There's my email address. You can find me that way. If it's best to set up some kind of video conference thing, we can do that too, but we'll organize that by starting off with the email. Okay. So to bullet point 1, formation of magma. How does magma form? Well, there are 3 ways. Let's think about what magma is. Magma is just melted rock that's below ground that has gotten to the point that it is melty. And there are 3 ways that rock can get that to that state. And the obvious one is you can increase the temperature of that rock. So if you've got some nice piece of granite down below ground and you can heat it up hot enough, it will melt and become magma. But there are 2 other ways to do that without playing with the temperature. You could also decrease the pressure. So if you're possible that you could decrease pressure on a rock, that may make it melty. So it's probably already going to be pretty warm below ground. So it's not like you can just, I guess theoretically, you could put a rock in a vacuum and it might partially melt. But we're not talking about theory. We're talking about the way this happens. My dog says he needs to pee again, but he's going to have to cross his legs for a few minutes. We'll get through this. And then the last thing is the addition of fluid. So if you have some rock below ground and water gets into it, or some other fluid gets into it, that can decrease the melting temperature. And so that will make that rock more easily melty. Okay, so those are the 3 ways that magma forms. 1, 2, and 3. Temperature, pressure, and fluids. 2. What is volcanism? Volcanism is a big word, but really it's a simple idea. Here's the textbook definition. Any activity that includes the movement of magma toward or onto Earth's surface. So that's it. It's just volcanism is making magma move. And it doesn't even have to quite get to the Earth's surface to still be called volcanism. So maybe the magma will just move partially upward. Magma is less dense than the surrounding rock, so it will rise. It'll bubble up like a cork bobbing on the surface of the water. It will want to get to the surface. So, but if it doesn't quite make it there, that's still volcanism. 2 other terms you should know. Lava is magma that flows onto Earth's surface. It's not fair. I don't like it, but science has 2 different words for the same stuff. Magma while it's below ground, lava when it flows out of a volcano and is on Earth's surface, above ground. Oh, and I use the last word, volcano. Okay, it is just a crack in the ground, a vent or a fissure in Earth's surface through which magma and gases are expelled. So it doesn't have to look like a big mountain with a hole on the top. It can look a lot of different ways. In fact, most volcanoes don't look like that. But the ones that are big and beautiful and snow-covered do, and those are the ones that we love and go climb and take pictures of. Okay. So those 3 terms you should know. Next, number 3, major volcanic zones. Where do volcanoes tend to form after all? there are three places they form. One of three places. They form in subduction zones, and this is a review from Plate Tectonics chapter, or they form at mid-ocean ridges, or they can form at hot spots. That's a term I haven't mentioned to you before, but we'll go into that. So here's subduction zone. Just to remind you, subduction zone, I think you can see my mouse, is where two plates are coming together, where plates collide. Whoops! Where plates collide. And so here I've got some colliding ocean crust colliding with continental crust, and as this crust gets driven down below ground, it gets hotter and hotter. So we're increasing the temperature, and eventually there may be some water as part of this rock, because water gets dragged down right here where this it gets kind of trapped among the rock and it gets dragged down, and so you've got the addition of fluids and you have an increase in temperature. So this rock will melt and that magma will rise to the surface and form volcanoes right there. This could happen even if it wasn't continental crust right here. What if it was two ocean crusts colliding? Ocean crust coming this way, ocean crust coming this way. Below ground, it might look the same. You've got this, one of them will be driven down below the other, and it will still melt, and magma will still rise to the surface, and it will form an island arc. So instead of being a line of volcanoes like you see all along the west coast of South America, it might be, and even North America, it might be a line of volcanoes, or like an arc of volcanoes like Japan or the Philippines, that forms when two ocean crusts collide. And the second place volcanoes can form at mid-ocean ridges. So this is a review, places where the ocean crust is splitting apart. You have magma rising to the surface. And if magma is working its way to the surface and it pops on through, that's called a volcano. Volcano is just any place that magma or gases are vented out through the Earth's surface. And the last place is the oddball one. It's actually how Hawaii forms. So Hawaii is like a textbook example of hot spots. Hot spots are far from a volcanic plate boundary. The Pacific plate's enormous, and Hawaii is right in the center of it and far from any plate boundary. What's going on beneath Hawaii is there is just a place in the mantle under Earth's crust, down under the lithosphere, where it is, for whatever reason, especially hot. And that heat is long-lasting. It has been around for millions of years, and that one spot is just burning away, and it's actually hot enough that it's melting rock above it through the lithosphere and forming these volcanoes. So forms a volcano right there at the hot spot, except that the tectonic plate is moving this way. So if you rewound the clock about 4 million years, this spot here this island would be over the hot spot, and it would be a brand new volcano. And as the plates move, these old volcanoes are moved away from the hot spot, so they go extinct, and some new volcano forms above the hot spot right there. Think of this like if you had some metal plate sliding above a welding torch. If you had the welding torch hot enough that it would melt a spot on the plate, and if you could hold the torch still but move the plate along, it would just leave these molten areas right above it. That's what's going on there. Okay, those thundering footsteps you hear are my welding son, who's wandering through the kitchen while I'm filming this. Do you want to say anything, welding son?
No, it's
okay.
Somewhat correct. So
okay, he disputes my welding knowledge, but I think the geology knowledge is correct. Okay, last thing you should know: intrusive activity. What happens above and below ground? Okay, so what I mean is this melting rock is kind of it's causing changes. It's causing physical changes. Stuff is getting pushed and shifted around. It's also causing some chemical changes. So here's what you should know. Magma below ground can melt rock, and that rock will fall into the magma perhaps, or get melted by the magma, and it becomes part of the magma. This magma doesn't have to reach Earth's surface. So you've seen this picture before, or something like it. If the magma doesn't reach Earth's surface and just freezes down there, this big magma chamber Any big magma chamber we call a pluton. An especially big one we call a batholith. A smaller one we call a stock. Then there are examples where magma might kind of work its way upward and like across the bedding planes, across the sedimentary rock there, and that's called a dike. And then something where it flows along the bedding plane or flows along the sedimentary rock is called a sill. And then occasionally it will form this lake of rock where it will come up to a surface and spread out, not really explode outward as a volcano, but will push stuff upward, and that's called a laccolith. So you've seen all those things before. That's what's happening with magma below ground. What's happening with lava above ground, you'll have to wait till the next video to find out. The next little section is on volcanic eruptions, and there are many ways that volcanoes can erupt, and we're going to classify those with the next video. Alrighty, your job now is to go be awesome.